how they work and feel comfortable with wideband oxygen sensors. I don't think most people do. I'm going to give you a quick overview here. And the reality of it is what we're looking at when we test doesn't have anything to do with how these work, but you still need to understand it. The best way that I can describe these is it's like it has two sensors built into it. It has one sensor, which is like its old oxygen sensor. It's looking for a 450 basically is its middle of the road. That's what it wants to see. And it's weighing, I like to think of this in terms of a scale, it's weighing what's in the exhaust versus what's in this first diffusion chamber. And it wants it to balance out basically. Okay, so that's what it's going for, is it's trying to get those to balance out. And then, but to get those to balance out, it is using the second sensor, and it's pumping air out of the second chamber into this one to get it to balance out. It's either adding or subtracting air to get it to balance out. And that second sensor reads a amperage, either a positive or negative amperage to show how much it's having to transfer from one to the other. Lean exhaust, you have a power or a positive amperage. It's pumping air in to that diffusion chamber. Rich exhaust, it's taking it out. And again, it's weighing, so it's trying to get them to weigh out is kind of the best way to describe it. But then the reality of it is understanding how this works, we need to know, but understanding the amperage draw on these, we really don't need to know because that's not what we use to diagnose them. What we use when we're looking at these is what we're really going off of is we're going off of the equivalency ratio. That's what's actually going to show up in the scan tool, and that's what's going to be the information that makes sense to us that we can actually make sense of. So equivalency ratio is lambda, is basically what this is. Lambda is stoichiometric, our 14.7, lambda is 1.00. And then when we go off of that, when we go above 1.00, we're adding fuel, so that's indicating a lean condition. And if we're under 1, if we're down in this case at 0.73, we're taking it away, so it's indicating a rich condition. So this is really the PID that you're looking at when you're looking at how these are working. Okay. One other thing that I'd throw out there, just real quick for looking at intermittent problems, rear oxygen sensors are extraordinarily important to air-fuel ratio in cars. The old idea that all they did was check the catalytic converter, if they are working or not, is completely wrong. They were lying to us from the start. They have always mattered to the air-fuel ratio adjustments in cars. So you need to make sure that you're looking at your rear oxygen sensor and making sure you're not having problems with those as well when you're doing testing for possible fuel issues or control issues. We touched on mode 6. The one thing I want to touch on this is enhanced DTC data. What that is when you have your DTCs and you've got your PO, whatever, and then you have a dash and you have 2 more digits after that, those 2 more digits are helping you to really pin down in that circuit or that system where it's seeing a problem. So instead of having to look at this picture, you can look at this part of the picture. Those enhanced data PIDs aren't always available just when you're pulling codes out. An example of this is like Toyota Prius. When we see some problems like with high voltage batteries and stuff like that, we have codes, but unless we go into the freeze frame data, we won't get the extra information of those codes for that enhanced data. So depending upon the manufacturer and what you're looking at, you might have that available. You just have to dig a little bit to see where it is sometimes. Permanent codes. What are permanent codes? Anybody? What? Hard codes. How do you get rid of them? Fix the problem. That's pretty much it. Permanent codes. You cannot clear permanent codes. You must fix the problem, and then the car must retest that circuit, pass that system, and that is what resets the codes on permanent codes. This is, again, another picture from the E-scan right here that we were talking about earlier. Okay? Test equipment. These are go in place of the relays plug into the top of them, and then you can test. What's important about this? What's important is that we now have smart circuits in cars. If you take the relay out or disturb that circuit to where it's no longer complete, the computer can see that and say, I'm not going to activate that circuit. So you might see no activation and think you have a problem, but the reality of it is you caused the problem because you opened that circuit, and that's actually what's causing it. I will point out I have had problems with these internally shorting out and frying a module on me, so use with caution. Diode relays, some relays have diodes in them. If you test them with the wrong polarity, you can fry the relay. So how do you know? Well, your best rule of thumb is just try and make sure when you're testing relays, if you're applying powers and grounds to them off of the car, make sure you're applying powers and grounds to the right side of the terminals so you don't fry relays. These are some test stuff. So this is a load box. This is basically putting multiple bulbs in line to load up the circuit. This is a relay test box. There's a few different manufacturers. This one's actually a homemade one. But there's like the U-Connect is the first one that comes to mind. That's what I had. And basically what it does is you hook this up to the different terminals on the relay and have the circuit connected so that it's working. And then as your different powers and grounds are being applied to that relay, you can see on this box that it's lighting up those LEDs. Now, where would this be? How would this be useful? Well, what if you have an intermittent problem? You need to go test drive this car. You know, you can't be under the hood testing while you're driving the car. We'll see a case study that we're going to use this in later. Headlights, we talked about that. Another thing that we talked about stressing circuits with wiggle tests and other stuff, hot and cold. Make sure you have stuff hooked up. We talked about lab scopes. The other thing is you can take your DVOMs, set them to minimum and maximum so that they will register minimum and maximum so you can do your tests and go back and look. Lab scopes. Variable input resistors, that's anything that changes. TPS, engine coolant temperature sensor. So we could have temperature, we could have mechanically moving them, change the signal. We could have vacuum control. Those are all different types of sensors that we could have. And they can have dropouts, they can have other issues. We need to know what we're looking for when we test them. But one of the ones that's showing here is a dropout in like a TPS. If you hook up your scan tool, you can graph these PIDs. If you do see a dropout in the scan tool graph, you have a problem. If you don't see a dropout in a scan tool graph, you may still have a problem. The scan tool can only capture at a much slower rate than what the computer actually sees. So to properly test these and make sure you don't have a problem, you have to hook them up to a lab scope. It's the only thing that can capture fast enough that you can see everything that the computer on the car is seeing. Hall effect sensors, we went over this kind of with the Ford. It needs to go all the way down, all the way up. It's looking at the peak, it's looking at the amplitude, it's looking at your rising and falling edges. They should be nice and straight up, straight down, very quick on and off. That's kind of what you're looking for. I'm not going to spend too much time on this. I'm just going to talk about it because we are running out of time and I realize that we're on this short of a time schedule. If you guys are using lab scopes, be careful using triggers. If you have triggers set before you see anything, you might not see anything. So what I recommend when you're using lab scopes, have your triggers off. Get your waveform, and then if you decide you want to use a trigger after you have a waveform, then with the info you have is figure out where you want to set that trigger. I very rarely use triggers, and if I do, I always make sure that I have a waveform first. The other thing is some lab scopes have a single shot option or some kind of single option. Understand that only gives you one quick capture and then it's stopping capture, so make sure you have that on, that's what you want. I highly recommend never using the auto trigger function on your lap scopes. It is a complete waste of time. It can mess you up more than help you. Electric motors. Here we have fuel pumps. You guys that do have lap scopes, any of you do testing with them on fuel pumps? Yes? Yes? No? Okay. So this is a low amp current probe test waveform of a fuel pump. So this is probably off of like a Dodge or a Chevy, you know, those ones that always fail, right? So why did they always fail? Well, they always failed because they ended up having problems with the connections right here. They had problems with either brushes wearing out, so basically they wore out and then the springs are sitting all the way out there and the brushes are moving around and it causes it to arc, or water in the fuel actually causing arcing on the commutators of the fuel pump as well and burning them. And that's generally what causes those to go bad. You know, if you have a fuel pump that you hit it with a hammer and then it works fine, it means you have a bad spot on the commutators, is basically what it is. It will definitely show up in a waveform. So this is our waveform here. You should have nice peaks like this. When you have them flattened off like this is showing bad contact, is what that's showing. It's showing worn out brushes. When you're measuring from the same point and then at least 6 over till the next same point that mirror images it, that is one revolution of that fuel pump. You can then take a time measurement, divide 60 seconds, and you can figure out your RPMs of your fuel pump. And then if you know what type of fuel pump it is, you know what it's supposed to do, then you can also see if the RPMs of the fuel pump are within spec of what it should be. Can you find intermittent problems with this? Oh, absolutely. How many of us have cars that come in on a tow truck, didn't start? When it gets to your shop, starts just fine. How many of us suspect it's a fuel pump? And then it got jiggled when they loaded it up, right? So do we sell them a fuel pump? How can we sell them a fuel pump? It starts just fine, but we know it's going to leave the shop and break down again and have to get towed in, right? So we can test the fuel pumps to see if there's a problem, and the problem's still going to be there. We can see it. It's an intermittent problem, but it's a problem that's actually always there that we can see if we know how to do the right testing in this case. So in this case, after doing the math, 4,600 RPMs. This waveform, we see the current rush in and just stay there. That fuel pump's not turning at all. Over here, this waviness that we kind of see is actually perfectly normal. That is not a problem. Some fuel pumps have that wave. But more where we have a problem is, again, the flat spots in the peaks of the waveform. Okay. So, wiring diagrams. Okay, I'm going to go through this quick. So this is a wiper motor on, I think it's a Chrysler 300. Okay, so our wiper motor is sitting down here. We can't really see it in this. We have our power feed in. It is switched power with the key on. It's feeding to our relays. So in this case, the power just continues right through our relays to this circuit board, which is part of the TIPM. It doesn't have a rear wiper blade, rear wiper motor. These are our constant grounds. So there's a constant ground hooked up to the wiper motor. That's why we have this one coming up from the bottom over here. And then we have our 2 constant grounds over here. This is our switched ground. So where is our switched ground coming from? Our switched ground is coming from this relay right here, because this relay is a switch. It is not an on and off, it is a switch. There's 2 different circuits depending upon what position it's in. It's going to complete 1 or 2 different circuits. So that's where our switch ground comes from on this. Oh, and then we have data lines, because again, we were talking about how important data is on these things. Everything's a computer, and there's no power set anymore. They're just computers talking to each other. So what else do we have in this? We have our wiper motor down here, and there's our ground to it. And then we have our steering control module, which is a really fancy name for a turn signal switch. So our turn signal switch is where our wiper controls are, right? So then it doesn't send power to anything, it sends data over data lines to the tip-em, and then that is what decides to turn on our wiper motors on this. So everything is computer controlled. It's not like the old days. I'm going to go past this so we can get into case studies because I think we've gone over it now. Alright, let's go through as many of these as we can before 9 o'clock. 13 Ford Exploder. Vehicle runs fine until it doesn't. Longer trips, 20 plus miles, the vehicle starts to run rough, check engine light comes on, sometimes it flashes. Good news, you've got some codes in there. You already know at least one of them is going to be a misfire at this point, right? But you have some codes to help send you in the right direction. These are the codes we have. Where do you guys want to start testing? Somebody give me somewhere to start testing. Fuel pressure?
Fuel trim.
Fuel trim.
Look at that.
Okay, fuel trim. There you go. Freeze frame data, which is the only thing that I have for a slide for you, sorry. But anyway, fuel trim. Okay, it's lean. Which I love this freeze frame data. It doesn't even have short-term fuel trim in it. But okay, we confirmed it's lean. It is lean on whatever bank it is. I think it was bank one. Yeah, it is lean on bank one. Now what?
When is it lean? I don't want to load.
It's lean when it's messing up. Constantly. When it's misfiring, it's lean. When it's misfiring, it's lean.
Check the battery.
Check the batteries. Okay. Good. That is never a wrong answer.
Oh, that's fucked up.
Never a wrong answer.
That's the best
Good
stuff.
idea. Battery test's okay. What do you want to test next?
How about oxygen?
Oxygen
sensors?
Just run the lead. Why don't you look at that?
Okay. I'm going to help send you in the right direction. It's only misfiring on one cylinder.
Spark plugs.
Okay, okay, it's only misfiring on one cylinder, so I think we can rule out fuel pump, we can rule out vacuum leak, right?
Fuel injector.
Okay, coil pack, fuel injector, that's where we would want to think of, right? So, injector maybe. Can we test both at the same time? Remember, we got to drive this thing 20 miles before it messes up. So, you know, let's hook up our scope, right? Let's hook up our scope to the injector, let's hook up our scope to the coil. Let's test them both at the same time, right? Now I know not all of you have scopes. You know, if you don't have a scope, how do you test it? Swap the coil, swap the spark plug, swap the injector. It's kind of about what you can do, right?
Yep.
Okay. So let's say we do have a scope, we can test, so I am on the fence. The book says that this is an injector waveform, and I don't know if I agree with that.
It's not.
I think this is a ignition coil waveform, is what I think it is. I think the person that wrote this book mislabeled this, personally. But anyway, so here's a waveform. When we were testing, after we warmed it up, we had our scope hooked up to everything. In one of the two circuits, we'll stay on the fence, I'm going to say it's a coil. One of the two circuits, we found a problem once it warmed up. That happened. So, what's wrong with it?
Bad wires. Bad wires.
Okay. Bad injector, bad coil, depending upon which one we're calling it. That seems to be the consensus. What?
That's a bad coil if you're looking at the feet. But while we're on lead.
You have a misfire cause a leak. Misfire can cause a car to run.
Yeah, no. Ignition, misfire, not usually.
Yeah. So, it can. So, this is neither. This is a bad driver in the computer. You can actually tell that from this waveform. You would be able to tell it better from this waveform if this voltage signal was on that cylinder. But you can actually tell it from this waveform too. But I'm going to tell you, everybody that swaps the coil, spark plug, and the injector around, you still had a misfire on cylinder 3. Because it wasn't the coil, the plug, or the injector. So how do you tell this? Generally, when a coil or a injector go bad, they short. So you generally see it go up and then start to current ramp. See it start to current ramp and then short out. Something along those lines where you're seeing a short in the waveform. What you're seeing in this current waveform is you're seeing it start to gather and store current, and then the more current it gets, it's having trouble holding ground, is what you're seeing here. So the driver is having trouble holding ground after this vehicle heats up, after you drive it about 20 miles. If you had the voltage waveform also, you would see your ground creeping off. Okay? That's what this one is. That's what it's called, that's what it's hot, and I really think that this is ignition. I see no pintle movement. I feel that this is ignition, but they're calling it an ejector, so we'll agree to disagree. Next one, 97 Suburban, intermittent blown ECM1 fuse.
Yikes.
It's been in a couple shops, or sorry, it's been at one shop, excuse me. They were not able to find the problem, so they replaced the fuse, handed the customer a handful of fuses, and said, here you go, see you later. And then when the customer ran out of fuses, he decided to bring it to your shop so that you could actually figure it out and fix it. So, customer did give you information when you grilled them that it does seem to happen on bumpy roads. Alright, no code stored in it. This is our wiring diagram. There's all kinds of stuff in this circuit. We've got injectors, vehicle control module, ignition coil, ignition module, crank position sensor. We've got all kinds of stuff in this circuit, right? So, how are we going to test it? I'm going to tell you how to test it because we're running short of time here. So, one is, I think we would start with wiggle testing this to see, I think almost everybody thinks something is shorting to ground, whether it's a wire or a component. So I think the first thing that we should do is wiggle test the wiring on this. So first we're going to do our locking test, all right? And then we're going to actually grab wires and wiggle stuff around by hand. If we find it and it blows while we're doing that, I think we'll find the problem already because we know around where we're moving our frickin' wires at this point, right? I think we can find the break in the short. What if it doesn't blow? What if it doesn't blow? Do you want to spend the time going over every inch of the wiring in this car that runs to all of those things? So what I would do is, I have a kind of splice area here where everything splices together. I'm going to go in, I'm going to cut this wiring harness apart, and I'm going to install fuses and break this thing up into different parts of a wiring harness. So I'm going to say, here's a fuse for this, here's a fuse for that portion, here's a fuse for that portion. Here's your keys back, Mr. Customer. When it blows, bring it back to me. Here's another fuse for you. Here's where they all are. Just pay attention to which one blows and tell me. When it comes back, you know where to look, right? The problem in this case was a bad wire at the EGR valve, shorting out around the EGR valve. CRV. You got a 1077 intake manifold runner code. The way this works, there is vacuum supplied to a solenoid which controls it. It's a control solenoid. When that solenoid turns on, it sends that vacuum to an actuator which mechanically moves those valves inside the intake manifold. And there is a sensor attached to them so the computer can see that they move. Pretty simple. It's already been to quite a few shops and they couldn't figure it out, so I start with level 2 diagnostic now. When somebody else can't figure it out and it comes to me, it's $440 for me to look at your car. Yep.
Oh.
Here's our wiring diagram, so we can figure out what's what. Well, it looks like they already put something on it there. So basically, we test everything with it sitting there. We test that solenoid, it has vacuum to it, it sends vacuum when we supply power and ground to it. We test the vacuum actuator, it moves, it holds vacuum. We test the sensor, it moves with the sensor. We grab it, move it, and everything looks great. So everything looks great for us when we're sitting there in the shop testing it. We go drive it. As it heats up, it starts to act up on us and we see a problem. What do you guys think the problem is?
Stuck flap.
Losing vacuum?
What?
Losing vacuum?
Nope.
Stuck.
It's sticking. Everything's plastic. Or sorry, it's high quality plastique that they use. Plastique, yeah, it's the high quality stuff. As it heats up, it's warping and it's sticking. So it doesn't test bad in the shop because everything's cold, everything's working in the shop. It tests bad when it heats up because that valve is actually binding inside the intake manifold. Replace the entire intake manifold. They sell the valve separately, do not make that mistake. Just like with BMW valve covers, if the valve cover gasket is leaking and it is a plastic valve cover, replace the valve cover. Do not replace the valve cover gasket. Plus it costs a lot more. You get to make a lot more off the job that way. So anyway, after you're done, make sure you re-test drive the vehicle and make sure it's fixed before you give it back to the customer. 05 Envoy, Intermittent dead battery. Okay, I like this one here. This is an important case study, and as long as we get through this one, I'll be happy. How do you guys test for parasitic draws?
Put a hand clamp on a negative battery.
Okay.
Watch the current draw, everything's sleep.
Okay.
See what you got. So
That's a backboard is fast.
half a millivolt, we got a problem.
Okay.
Don't start pulling fuses.
Okay. So I think that's
Check, voltage drop across the fuse, positive one. That's how I start.
That is the perfect answer to that question. My next question would be, is everybody that didn't know a voltage drop in here sure as heck is not testing parasitic drop? Why don't you want to disconnect fuses or disconnect the battery and put your amp meter in line? Because what happens when you do that? One, you're waking up computers. Two, you might have just fixed the problem. Okay, so in this case, this car went to multiple shops, couldn't figure it out. The last shop said they did figure it out, and then, you know, a couple weeks after that, it had a dead battery again. Customer did state that it seems to happen after it rains, so we're considering that it might be a water issue. So it comes into your shop, it's not acting up. We put an amp clamp around the battery cable. We don't see a current draw, so we hose it down. The whole car down with water, and after a little bit and enough water, excuse me,
Section by section.
we get our parasitic drop. So our intermittent problem we were able to duplicate because we got enough information from the customer. Now we get to go diagnose it. So we amp clamp it, and then we go to our batteries and our fuses, and we start testing across the fuses, so that's that it's showing it. You can use an amp clamp without a scope. You can use an amp clamp with a digital voltmeter. You can use an amp clamp with a graphing digital voltmeter. You do not have to have a scope to do this. And then you're going to go and test across the fuses and see which one's pulling some voltage drop across them. There are charts that can convert what you see on voltage drop on different types of fuses to how much amperage draw there is. Don't stop at the first fuse. You might have more than one fuse pulling amperage. In this case, we had two. But we're going to go back here for a second. What's this picture over here in the top right? Thermal imaging. So you mean instead of doing all this, I can just take a camera and say, hey, is that a fuse? Well, I'll tell you one better. You can take that camera, if you have the time you want to do this, you can park the car inside, shut everything down, open the doors, make sure everything's shut off, let it sit overnight, Ideally, put a trickle charger on it too so the battery doesn't go dead. And first thing in the morning when everything is cold, before anybody's gone around it or anything's been done around it, look at the whole car with the thermal imaging camera and guess what's going to be hot? Your draw, wherever it is in that car, because it's going to be hot. It's been drawing power. Okay? I have a thermal imaging camera that I use. It's a FLIR one. It plugs into my phone. It costs me about $200. It's not that bad. So we had 2 fuses. They are these 2 fuses. We've got liftgate module, driver and passenger memory seat modules. On this fuse we've got window wiper motor and liftgate module. Where are we going to go? Wiper motor? How about liftgate module? It's on both fuses. Right? What shares our common problems are liftgate module, right? So, wiring diagrams can have wrong information. In this case, you have 3 wires going to it, and it says one of those is connector 8. Why would it show that there's at least 8 wires, but only 3 go to it? Because not all of the information is there. When you're looking at a wiring diagram, components that have solid lines around them mean everything in that component is in that picture. If it has dashed lines around it, like this one up here, means there is more in that component than what is showing on this diagram. Okay, in this case we see our 2 fuses, our liftgate module. We go and look, we have water in there, we disconnect it, we lose our current draw. Fix it, make sure you fix the water intrusion problem. You can either reseal the window or drill a hole in the bottom of it. This is Louisiana, so you know, however they want to do it, right?
That's fucked up.
Okay, we replaced it and fixed the problem. Here's another quick look at another way that you can do this, and then we're going to
That's my
in
favorite
this
tool.
class because
It's
it's
Tech
9.
2, bitch.
This is the Tech 2. This is again OEM scanner capabilities. What can you do if you have these? So you
Like
can do basically a module roll call is what this is and say, hey, who's on the car and are you active? So you come back, these modules are on the car, they respond to you. These say that they are currently inactive. This one says it is active, which that's the transfer case. 4-wheel drive button was on. But then you also have over here, this is a count of how active they have been. Everybody's 2 except for the one that's still on and the liftgate module. So maybe we have a problem there. Once we fix it, everybody's at 2. Alright, I am going to call this quits because they are going to kick us out. I'm going to put my email address back up here. If you guys